Alright guys, welcome back to another video. In this video we'll talk about metals. So we know in the periodic table we can say that all the elements are divided into two categories, metals and non-metals. There's also transition metals which are in between, somewhere between metals and non-metals, but today we'll discuss about metals. Alright, so let's start with the physical properties of metals. First of all, metals have high melting and boiling point. How do they have high melting and boiling point? Because what is the structure of metals? There is a metallic bonding, right? So there is a lattice of positive ions like this, and they are surrounded by a sea of negative electrons, and there is a very high electrostatic force between both of these ions, which give it a high melting and boiling point. Next point is that metals are good heat and electrical conductor. Why? Because of these free ions. Okay, these ions are also called as delocalized electrons because they can travel around the metal structure and they can carry heat and electricity from one part to another. If you have studied physics, you know our current is basically movement of electrons. So these delocalized electrons contribute to the good electrical and heat conductivity of metals. Third point is they have very high density. Next is they are malleable. What is the meaning of malleable? Malleable means that they can be they can be cut into layers, into thin layers. Why? Because layers of metal ions can slide over each other. Look, if this is our lattice, as you can see here, if we apply some force on one side, the lattice can move. It would be something like this. The layers can slide over. The next property is that they are ductile. Metals can be pulled into wires without breaking. Therefore, metals are used as wire, for example, copper wires. Next, metals are also very shiny. This is one of their properties. They're not dull like lead. They're shiny like gold. And lastly, they have a property of sonorosity. So, what is sonorosity? It's when you ring or when you hit a metal, it produces a ringing sound. Alright, so now we'll discuss use of some common metals and why. So first of all, we have aluminum. Now aluminum is used to make aircraft bodies. Why is it used to make aircraft bodies? Because aluminum has comparatively lower density than other metals. So it's a lower density that means it's a good choice for it to fly, for airplanes to fly. Low density is desirable. Next, saucepans are also made up of aluminum. Why? Because they have good thermal conductivity, just like other metals. They conduct heat. And finally, they are also used to make food containers. Why? Because they are resistant to corrosion. If the metal container, aluminum container, was not resistant to corrosion, it would spoil the food. To prevent that, we use a material that is resistant to corrosion. Next, electrical wires are made up of copper. As we studied before, metals are ductile, and also because they are good electrical conductor. Copper is an excellent choice. Next point is steel. So what is steel made up of? Steel is generally made up of carbon and iron. But we can do some variation. That means we can add more carbon. We can change the percentage of carbon more or less and add some more to have different types of steels. So now we'll talk about stainless, high carbon, and mild steel. First of all is stainless steel. As the name suggests, it does not corrode. What is it made up of? Stainless steel is made up of nickel. It's also made up of chromium, and finally it has iron. Used to make surgical instruments and chemical reaction vessels because it's highly resistant to corrosion. It does not corrode easily. Stainless steel is also used in cutlery. Why? Because as well as because of its hardness. They're used to make surgical because of these properties: hardness, highly resistant to corrosion. It's used to make cutlery, chemical reaction vessels, and surgical instruments. Next, we have high carbon steel. So in high carbon steel, there is carbon, and the percentage of carbon is very high. Now, it's used in razor blades as well as high-speed cutting tools. Finally, we have mild steel. It says mild. That means the percentage of carbon is not very high. What are its uses? It's used to make car bodies. It's used in machinery. It's also used to make wires. Alright, now we're going to talk about a new type of material which is called alloys. So alloys is basically a mixture of material that has metals and non-metals. Now, why do we do that? We do that when we want to create a new material that might be stronger than the metal or non-metal used, or it might have a higher conductivity to increase the conductivity, or basically to change or enhance the properties. We use alloys. Now, one example is brass. What is brass? Brass is an alloy, and it is made up of copper as well as zinc. Now, what is the percentage of both of them? We have 65% copper and 35% zinc. So when we have this material which are combined together, note they are not reacting together. They're just like combined together to form a mixture. We get brass. Now let's see how is an alloy formed. So as you can see here, we have a metal. This is basically a lattice of positive ions which is surrounded by a sea of negative electrons. Now when the metal is melted and allowed to cool, so it loses its fixed structure and it dislocates into something like this structure. Basically, when when we have this as well as another, for example, let's say this one is copper, this is copper and zinc. When both of them are melted and they are mixed together, one metal enters into the other metal, for example, something like this, giving rise to a stronger alloy structure. And this is the lattice structure you get. You can see blue represents copper and red represents zinc. They have both combined together and mixed together into one alloy. These metal ions will have different sizes depending on the MR or AR of the element. So if you apply some force here, the layers are not going to slide over each other because of the difference in size. This makes this alloy of brass. It has copper and zinc, so this is brass, more stronger, and it's used in various places because of its specific properties. Alright, now we'll talk about reaction of metals. To do that, we have something called a reactivity series. What is reactivity series? Basically, it's we have arranged the metal according to their reactivity. This is the reactivity series. You're supposed to memorize this. As you go down, the metals on the top are highly reactive. Reactivity decreases as you go down. Now this is potassium and this is aluminum, right? We can say metals from potassium to aluminum, they are considered so highly reactive that they tarnish at room temperature and air. From potassium to aluminum, these elements. Alright, now we will discuss the reaction of metals with oxygen. So we have the reactivity series of elements of metals and we have arranged them according to their reactivity. As you go down, the reactivity decreases. So elements that are on the top, they react very violently and vigorously with oxygen, whereas elements which are at the bottom, for example silver, gold and platinum, they don't even react with oxygen. So can you try to do this and balance these equations? Remember that when a metal and oxygen react, we get a metal oxide. Try to do this and I will reveal the answer after that. Alright, so these are the products with balanced equations. Now if you notice, for aluminum we have Al2O3. This is the aluminum oxide. For iron we have FeO, but there are two types of iron oxide, so we have written two equations, ferrous and ferric, different iron ions. Now how did we find the chemical formula of these metal ions? It depends on their ions. For example, potassium forms a K plus ion and oxygen is -2. Because potassium is in group 1, it can lose 1 electron. Oxygen gains 2 electrons. So we need 2 potassium and 1 oxygen to balance this. Now if we look at calcium is in group 2. So it forms Ca plus 2 ion and oxygen is in -2 and we'll get CaO. Just like that, for iron, it's a transition metal, and it can have variable ionic state including Fe+2 and Fe+3, but oxygen is only -2. So this forms FeO, and this is Fe2. This goes there, Fe2O3, and so on. Last three do not react. So we can summarize that metal plus oxygen give us a metal oxide. Alright, now moving on. We can, if we have some element, for example, barium, lithium, sodium, copper, calcium, potassium, if we burn them in Bunsen burner flame, that means they are reacting with oxygen, we get these characteristic flame colors. If we see, barium always gives us a light green color. Potassium gives us a purple flame color. Why do you think this happens? So basically, the reason behind that is when our metal ions are heated, when the metal ions, for example, lithium ion, sodium ion, they are heated, the electrons get excited and move to the higher energy level. For example, if this is a nucleus and this is electron moves to the next shell. And then when they return from the higher shell back to the previous shell, this change in energy is released in the form of visible light. And since every metal has a difference in energy level, we get a characteristic flame color. Okay, now we will discuss reaction of metals with wire, starting from potassium, sodium, and lithium. Now, can you try to balance these? Remember, when metal and water react, we get metal hydroxide and hydrogen. So this is the balance equation. When potassium, sodium, and lithium react with water, we get a metal hydroxide and hydrogen gas. So now let's write down the observation. So we can see hydrogen gas is formed. Therefore, we can say we get bubbles of colorless gas. Colorless as well as odorless because there is no smell. Colorless, odorless gas. Secondly, we can observe flame colors. When they are burned, we get characteristic flame colors. And finally, these float. Okay. Now, what about calcium? What happens when calcium is mixed with water? Again, we get a hydroxide and hydrogen only. So what do you get? So we get calcium hydroxide and hydrogen with 2 water molecules. What are the observation? We have no flame colors this time. With calcium hydroxide, we have no flame colors. We have hydrogen gas. So again, we get bubbles of colorless, odorless gas. And then finally, when we add this in water, the calcium pieces were added to water, and these pieces, when they react, they move up and down in the beaker. For example, this is the beaker with water, and we add our calcium pieces. They float up and down. Okay, now we'll talk about magnesium. So magnesium does react with water, but it reacts really, really slowly. And what does it give? It gives us magnesium hydroxide, MgOH2 plus hydrogen. But what happens if we try to react magnesium with steam? This is steam in a gaseous form. What happens is that it reacts readily, and the products are this time they're different. We get magnesium oxide and hydrogen. Now, what about aluminum, zinc, and iron? They react only with steam, and they give us metal oxide plus hydrogen. Can you try to balance these? So this is what we get. Iron is also written as FeO dot Fe2O3. This is how, and how do we name it? We call it tri-iron tetraoxide because we have 4 oxygen and we have 3 iron. Now, so we saw that magnesium can react with steam to give us magnesium oxide plus hydrogen. So let's see, let's try to see if we have an experimental setup like this. So here we have a closed system where we have a magnesium ribbon there. Steam is allowed to enter. What happens? Steam and magnesium react and hydrogen gas is released. Steam is magnesium is converted into magnesium oxide. Let's try to write down this reaction. Magnesium plus water in the form of gas, which is steam. We get MgO plus hydrogen gas. So what really happened here is that magnesium, which was MgO, magnesium has oxidized, but water has reduced to hydrogen. So this is a reduction. We call this type of reaction a redox reaction. Read for reduction, ox for oxidation. So this is a redox reaction. Now, whenever a material oxidizes, it's called a reducing agent. It helps the other material to reduce. And whenever a material reduces, it's called an oxidizing agent because it helps the other material to oxidize. Now, if we talk about some observations, what are some observations we can note? A, we can observe that a hydrogen gas is being released. Now, the test for hydrogen is that the splint will give a popping sound, right? The hydrogen test. So we can know that there is hydrogen gas. Secondly, we can observe that the magnesium ribbon has turned into magnesium oxide. How do we know? The silvery gray color turns into a white solid. So these are two observations that we have noticed. Now there's a question. Why do you think there is an outlet provided for hydrogen gas? What if this thing was just closed and the hydrogen gas would stay inside that's being produced? What do you think is the reason for that? Basically, we have this outlet to allow hydrogen gas to escape the vessels so that the pressure inside the vessel does not increase too much that it could break the vessel. To prevent that, we have an outlet for hydrogen gas. Alright, now we'll study reaction of metals with acid. So if we have potassium, sodium and lithium, these are on the very top of reactivity series. We do not react them with acid. Why not? Because they are so violent and these type of reactions are dangerous to carry. So potassium, sodium and lithium are not to be reacted with acids. Now, what about other materials? What happens when a metal is reacted with acid? We get salt plus hydrogen gas. Please try to react calcium and magnesium with hydrochloric acid. Also try to react aluminum with different types of acid. So these are the balanced equation. Calcium plus hydrochloric acid forms calcium chloride and hydrogen gas. Magnesium forms magnesium chloride and hydrogen gas. Now calcium can also react with all kinds of acid, calcium and magnesium, as well as aluminum. So we get aluminum chloride, aluminum nitrate and aluminum sulfate. Remember, the ionic state of aluminum is Al plus 3. Chloride is -1, nitrate is minus as well, and sulfate is SO4 -2. Now, one important thing to notice about aluminum is that when you have aluminum block, for example, this aluminum gradually combines with oxygen and it forms a protective layer on top of it. This is a protective layer of Al2O3. So this kind of gets covered by it. It tarnishes. When this aluminum block has a layer of Al2O3 on top of it, it prevents any reaction with other materials. So you cannot directly combine aluminum with aluminum that has been left out for some time with hydrochloric acid. So first of all, you need to remove and clear this layer. When you remove this layer, you get pure aluminum, and then you can react this aluminum block with your hydrochloric acid or other whatever material. It shows its true reactivity after removing the layer. Now, what about these materials? Can you try to react them? These are the balance equation. Zinc gives zinc nitrate. Iron, we have two ionic states, ferrous and ferric. Fe plus 2, Fe plus 3. We get these two salts and hydrogen gas. With lead, we get lead nitrate. Now, what about copper? So the thing is, copper, when it's reacted with hydrochloric acid or sulfuric acid, there is no reaction. Copper only reacts with nitric acid to give us copper nitrate. So here, copper plus nitric acid gives us copper carbonate plus hydrogen. Now, we just said that copper does not react with sulfuric acid. What happens if we want copper sulfate? What do? We can't directly react sulfuric acid with copper, but we can react with compounds of copper. For example, copper carbonate and copper oxide. This will react with sulfuric acid to give us copper sulfate. Can you try to balance these and write products? Okay, so this is what we get. We get copper sulfate in both cases as well as water, but when we have copper carbonate, we get water as well. Now, what about silver, gold, and platinum? They do not react with acid. There is no reaction. Now we'll discuss the last part for this video, which is the displacement reaction. This is very important, but it's very easy. So in displacement reaction, what happens is, this is the reactivity series, right? And the metals on the top are more reactive compared to the metals on the bottom. So the more reactive metal is going to replace the less reactive metal from our reaction. Okay, let's understand this with an example. For example, if we have sodium, and this is allowed to react with, for example, zinc oxide. Now, where is sodium in the reactivity series? Sodium is here. What about zinc? Zinc is at the bottom. Since sodium is more reactive than zinc, sodium is going to replace this zinc and it will form NaO, and zinc will be separated. So this would be actually Na2O, and we get 2 sodium, and this is balanced. Now, what if we had sodium, but this sodium was reacted with potassium oxide? If we compare sodium with potassium, we can say that potassium is more reactive. So there is going to be no reaction. What happens if displacement reaction occurs in solution? So basically, metal slowly disappears from the solution. So magnesium and copper sulfate. Magnesium is on the top, copper is at the bottom. So magnesium will replace the copper, and we get magnesium sulfate. Well, copper remains as a solid. Let's observe it. So here we had a blue copper sulfate solution. It's the copper is displayed, and we get displaced, and we get copper as a solid, while magnesium sulfate solution is colorless, and we can observe that the color of the solution has changed from blue to colorless.